we are done with the atomic theory and model. Now let's proceed on how electrons are arranged in atoms. So as we said a while ago that atoms are the basic units of matter and the defining structure of elements. The term atom comes from the Greek word atomos, which means indivisible, because it was once thought that the atoms were the smallest things in the universe and could not be divided. We now know that atoms are made up of three particles: the protons, neutrons, and electrons, which are composed of even smaller particles such as quarks. The atoms of each element contain a characteristic number of protons. In fact, the number of protons describes what atom we are looking at. The number of protons of an atom is called the atomic number. Forms of the same atom that differ only in their number of neutrons are called the isotopes, and together the number of protons and the number of neutrons determine an element's mass number. So mass number is equal to the number of protons plus the number of your neutrons. Just like for our example now. So A here is the mass number in which it is the number of protons plus neutrons. And Z is your atomic number of an element. Atomic number of an element is equal to the number of protons in its nucleus and to the number of electrons around the nucleus in a neutral atom. And X here, the symbol is an element symbol. Okay, for example, we have an an element Na in which this is the symbol. So Na is a sodium. The mass number of sodium is 23 and the atomic number is 11. So the atomic mass of sodium is 22.989,769,282. So now, let's proceed to electron configuration. So what is electron configuration? The electron configuration of an atom is the representation of the arrangement of electrons distributed among the orbital shells and subshells. Now, commonly, the electron configuration is used to describe the orbitals of an atom in its ground state, but it can also be used to represent an atom that has ionized into a cation or an ion by compensating with the loss of or gain of electrons in their subsequent orbitals. Many of the physical and chemical properties of elements can be correlated to their unique electron configurations. The valence electrons in the outermost shell, are the determining factor for the unique chemistry of the element. So these are an example of electronic configuration. So this is lithium. So this is the atomic number. The atomic number of lithium is 3. Okay. So the electron configuration is 1s2 and 2s1. So these are your subshells, ds, pdf, in which that is in our periodic table of elements, wherein S is in 2, P is 6, D is 10, and F is 14. So just like the carbon, that has 6 atomic number. Now, this is the electronic configuration of your carbon. It has 1s2, 2s2, and 2p2. Why not 6? Because the atomic number indicated in our subshells, it has, so 2 plus 2 plus 2 is equal to 6. So there are 6 subshells. So carbon has an atomic number of 6, and so on and so forth for the oxygen, neon, sodium, aluminum, phosphorus, and all the atomic number or all the elements in the periodic table of elements. So now, let's proceed to valence electrons. What is valence electrons? So a valence electron is an electron that is associated with an atom and that can participate in the formation of a chemical band in a single covalent band, but atoms in the band contribute one valence electron in order to form a shared pair. So this is an example of our valence electron. We will first write the electron configuration of an element. So our example is the element zinc. So zinc is in, what is the atomic number of zinc? So zinc, the atomic number of zinc is 30. So first, we will write the electron configuration. So the electron configuration of zinc is 1s2, 2s2, 2p6, 3s2, 3p6, and 3d10. Now, how can we find the valence electrons or the valence shell? So we have to look first the greatest base number in the electron configuration, and which is the 4. So your 4s2 now is your valence shell. Now, the question is, how many valence in zinc? So there are two valence. So what charge will a zinc ion have? We have two positive. So that is now the valence electrons. So look for the greatest base number in the electron configuration. Next. So we will proceed now the types of chemical band. Atoms tend to arrange themselves in the most stable patterns possible, which means that they have a tendency to complete or fill their outermost electron orbits. So they join with other atoms to do just that. The force that holds atoms together in collections, known as molecules, referred to as a chemical band. So there are two types of chemical bonds, or there are two main types and some secondary types of chemical bonds, which is the first bond is the ionic bond. So ionic bonding involves a transfer of an electron. So one atom gains an electron while one atom loses an electron. So one of the resulting ions carries a negative charge, which is an ion, and the other ion carries a positive charge, which is the cation. Because opposite charges attract, the atoms bond together to form a molecule. Now, the one that loses an electron is a metal. So the metal loses an electrons to become a positively charged cations. And also, the nonmetal accepts those electrons to become a negatively charged ion. So ionic bonds require an electron donor of that metal and an electron acceptor, a non-metal. Now, how about covalent band? So the most common band in organic molecules, a covalent band involves the sharing of electrons between two atoms. The pair of shared electrons forms a new orbit that extends around the nuclei of both atoms, producing a molecule. So there are two secondary types of covalent bonds that are relevant to biology: the polar bonds and the hydrogen bonds. Okay, now, what is Lewis symbols? So Lewis symbols, these are an electrons that are represented as dots. Only valence electrons are used. So we will atomic hydrogen is has only one hydrogen or the one atom or the one valence electrons. So the valence electrons we will base from the valence shell. The valence shell describes their atomic electrons or their electrons. So atomic lithium has one and atomic sodium has one also. These elements has only one dot. These are an example of the Lewis symbol. The lithium. Okay, so these are the electron configuration. And this one, let's proceed to oxygen. So oxygen, this is now the valence shell. So it has a base unit of 2. Now, this is your valence shell. Valence shell 2 plus 4, it has 6 valence shells. So these valence shells define how many Lewis dot structures that surrounds the elements. So 6. So we have to put 6 Lewis dot. 1, 2, 3, 4, 5, 6. Another example for fluorine. Fluorine, it has the 7 valence electrons. So you have to put 7 Lewis dot. 1, 2, 3, 4, 5, 6, and so on and so forth. So that is the Lewis symbol. Next, what is the octet rule? So octet rule states that elements gain or lose electrons to attain an electron configuration of the nearest noble gas. So why elements follow the octet rule? So atoms follow the octet rule because they always seek the most stable electron configuration. Following the octet rule results in completely fill the s and p orbitals in an atom's outermost energy level. Low atomic weight elements, the first 20 elements, are most likely to adhere to the octet rule. So that is the octet rule. Now, let's proceed to ionic bond, the example of ionic bond. So we have here the sodium and the chlorine. Now this sodium, it has one valence electrons, and the chlorine, it has 7 electrons. So as we've said a while ago that we have to follow the octet rule to become stable of the element. Now this metal loses an electrons. She or it will give an electron to chlorine so that chlorine will be more stable. Now sodium loses electrons. Sodium become positively charged. And now chlorine, it has 8 valence electrons. It is now stable because sodium shared electrons to chlorine. And now, since chlorine accepts an electron, it will become positively charged. Next, another example. How about this one? The magnesium. Magnesium has 2 valence electrons and fluorine 7. Now, how can this magnesium give its 2 electrons? So we have to put 2 chlorine so that this magnesium will give equally or transfer equally its electron. So now magnesium give to its electron to chlorine and another to chlorine. Now, so it will become magnesium 2 positive. Why 2? Because 2 electrons releases. And chlorine will become negatively charged and will become stable. following the octet rule. Now, let's proceed to covalent band. So covalent band, when nonmetallic elements react with other nonmetallic elements, they share electrons in order to obtain 8 valence electrons. So this one, unlike the ionic band, they have to transfer an electron. In covalent band, they do not. They have to share electrons to obtain 8 valence electrons. And these elements, they are both non-metal. They just have to share their electrons in order to satisfy the octet rule. Just like this example, our fluorine atom. They have both 7 electrons. So they each require one more electron to satisfy the octet rule. So they have to share their electrons with each other. So that is the covalent band. How about another one? We have the double and triple covalent band. This is covalent band. This is double covalent band. The oxygen. Oxygen, it has 5 or 6 electrons. So in order to become stable, they have to share electrons with each other using double band. So now this will become the product 2, 4, 2, 4, 6, 8. Now it will become stable. And next, the nitrogen atoms. Nitrogen atoms, the triple band. And also the carbon dioxide, as you can see on our structures. To become stable, they have to share their electrons with each other. So that is now our lesson.